right, so we move on to the next speaker, Parvathy. Parvathy is still there. Let me see.
Hi, Lavin. Yes, I'm
Yeah.
here.
Hi.
Hi.
So really thank Parvathy calling all the way from Europe. Yeah, I'd like to introduce you. Have you seen Parvathy's bio, you guys? Whenever I think of data science, I think of Parvathy. So there you go. And so I let Parvathy, you introduce yourself, your background, and Parvathy is our STEAM platform leaders as well. So if you look at our website, we have Parvathy been working with us for a long time since my Singapore days. It's been my inspiration on all these web applications and automations and how to use data to to improve efficiency of whatever we're doing, including management. So she's been my inspiration. We worked together at the Solar Research Institute in Singapore back in, was it 4 years ago now? 4 or 5 years ago, it's a long time. So yeah, Parvathy, I'll let you introduce yourself a little bit, and we look forward to your sharing on data science, how data science can help all of us here.
Yeah, first of all, thank you so much, Lavin, for this opportunity and for inviting me. Lavin said that I am her inspiration, and that means a lot to me because Lavin is, of course, my mentor and have been an inspiration throughout. I met, like she mentioned, I met her in Singapore, but right from there, she was a proponent of youth entrepreneurship and have actually given me a lot of motivation to end up where I am today. So thanks, Lavin, for that and for your kind words. Really appreciate it. I'm Parvathy. I'm originally from Kerala in India. Currently, I'm based out of Netherlands. So my background is I have a bachelor's in electrical and electronics. I did a master's in energy management and climate change technology. And then after that, I moved to Singapore. I worked there in research and development for almost 2.5 years. And then I decided that I want to focus really on how to use data science and AI in sustainable development sector. So I moved to Netherlands to pursue a professional doctorate in data science. And I focused mostly on application of data science in sustainable development goals related topics. After graduation, I started working at as a consultant with World Bank. So this is my 3rd year in World Bank. As a consultant, I advise on a series of data science projects there. I'm also a data science lead for one of the next gen data for policy initiative of UNDP India. So I advise them on how data and digital can be used in food and agriculture systems. I apologize if my voice is not clear. Sometimes I have a small throat issue. So please feel free to interrupt me and let me know if you cannot hear something or if you have any question. You don't need to wait until the end so that we can make it a bit more interactive. And yeah, you can interrupt me anytime to ask questions.
Parvathy, just before you continue, I just want to highlight now a lot of you here. Now, Parvathy got her PhD in 2 years in a top data science institute in the Netherlands or in Europe. And she had her master's degree in India. She worked in Singapore, and she's still very, very young. You're 31, Parvathy? I still remember you in your 20s. So it's really, really young. She's now a very important consultant for World Bank in the data science, addressing many, many issues in many relevant data science projects in World Bank and covering many countries also, right? Especially in the developing countries. So I just want you to appreciate, when I met Parvathy, she was a researcher, right? She had and at that time, I have to tell you another story, that she tried to get into the PhD program in NUS, and NUS, being very narrow-minded, I must say, didn't give her the opportunity. And she ended up getting a much better opportunity in the Netherlands, and she finished her PhD in 2 years' time. And it was an amazing program she did. And she won almost every hackathon possible. So I want to make one point, whether it's data science or emerging technologies, if you use it for the sake of the technology, but not to solve a problem,
it usually end up not being used or scaled. But if you try to use these technologies, including data science, people think of data science as a silver bullet to solve all the problems. I think that's not true. If you use data science to solve problems that actually can be solved with data, and in conjunction with a lot of domain knowledge and expertise on the field, then data can be a really, really, really powerful technology and tool. And that's why businesses around the globe are using data science in their operations. At the same time, public sector organizations are also using data a lot. So I don't think in 1 hour I can cover all aspects of data science. But what I want as the key takeaway from this session is what is possible with data science. Like, what are some of the applications? What are some of the use cases where data can be used? And what is kind of like the tool set required for certain applications? So that will be the key takeaway that I hope you get from this session. So data science basically is about getting insights from data. So you are generating data every moment that we log into your Facebook or Instagram or any social media platform. And as you know, there are like satellites being deployed every month or every year to monitor Earth's condition. For example, collecting an enormous amount of satellite data, then pre-processing it to get Earth's conditions. There are sensors deployed everywhere to measure and monitor environmental conditions and so on. So data is being collected a lot. But what data science gives you the capability of is to use this data to actually come up with some actionable insights. So if you just use this data to make a nice graph and that's it, without having any engagement with the users on how to actually use this data, then it doesn't ultimately lead to an impact, or it doesn't ultimately lead to an innovation or a decision. So the capability of a data scientist should be to convert data that is derived from different sources to actionable insights. Now, for doing this, we don't just need like programming or mathematics and statistics skills. We need other additional expertise as well. For example, in technical skills, they might have to use Python or SQL or Tableau, any of these tools to analyze the data, to visualize it, maybe to run some algorithms on it. You need to write some mathematical models behind it. And that is encompassed in the technical skills. Secondly, once you have made this analysis, how will you communicate your results to the end users? So that will come in communication skills. Now, the third one, which many people try to ignore, but these days it's becoming more and more prominent, is the domain expertise. For example, if you're developing a data product for healthcare sector, do you really know your users? Do you understand the domain and the context in which you develop the solution or the product? So that is also important. Now, it doesn't mean that one person should have all these skills, because then we call them a unicorn, because they don't exist in most cases. But usually data science can be a team process. So in a team, you could have different skill sets which are working in a combined manner to actually deliver the data product. So these are some of the skills that are required for a successful data science project, but that does not really mean that you need everything in one person. It could be a team exercise. Now, I want to show this graph to show you what is possible with data science. Now, if you look at any data, you can tell what happened. So you just look at the historic data and you can say what happened. You take the example of COVID cases. So you look at the COVID cases across the globe and you see, okay, in this country, it's this, in this country, it's this. Yeah, you get an idea of what is happening in. The next level of analysis is called diagnostic analysis, where you see why did it happen. For example, why some countries the outbreak is more, why some countries they were able to successfully contain, why, what is the root cause of some of these things that you saw in the descriptive analytics. The third case is the predictive analytics. In prediction, you try to use this information that you got from descriptive and diagnostic to see, can you say what happened, what is going to happen tomorrow? Can you predict this country, there is going to be a rapid outbreak? Then the fourth one is prescriptive analytics. And people say that this is the one that gives most value. But to be honest, from my experience, I see all these four stages have value, its own value. In some projects, predictive itself is very powerful. But what prescriptive analytics tell you is, it can help you develop scenarios by which you can make things happen. For example, if I want to reduce the number of cases, what should I do? So I use COVID as an example because it's something that we can all relate to, but this is the exact same thing that you see in companies. In companies, you can see what is my sales today. So that is descriptive. What has been my sales for the past 1 month? That's descriptive. Why did my sales suddenly drop in January? Why did my sales suddenly increase in March? Those kind of questions is diagnostic. Can I predict what is my sales going to be after 3 years, 3 months? That will be predictive. And the fourth one, prescriptive, will be, if I want my sales to be X, or if I want to double my sales, what are the things that I should do in my process to achieve that? So how can you make it happen? Now, I have two examples for this, one from the public sector and one from private sector perspective, to give you more idea, because I feel that if you understand these four concepts, you can easily come up with use cases given your problem statement. For example, you are running a company, or you are working in a company, you get a problem, you can immediately say, okay, this is a predictive analytics problem. So I would need to do descriptive or diagnostic, but ultimately this is a predictive problem. Or I should brainstorm a bit more on the prescriptive part of it. So I have two examples for you, one from public sector. So please let me know if you see my screen map of Thailand. It's seen. Can you see my screen? Okay. Do you see on my screen a map of Thailand?
Yes.
Okay. Thanks. So basically what this shows is the population density, population distribution in the whole of Thailand. So you see here, of course, Bangkok metropolitan area, which is showing.
We can't hear. Sorry, we can't see. We only see your data as a sentence model.
Oh, wait. Let me show you the map again. Now, do you see a map of Thailand?
Yes.
Okay. Yeah. So, so this is basically a map of Thailand with population densities. And you can see here, this is the Bangkok metropolitan area, which is dark blue, which means the population density is high here. So just a visualization of this shows you, okay, population densities is such and such in Thailand. So this is a descriptive map, which does not tell you any thing on why the population density is like that. It doesn't give you more information than what is there. Now, suppose my use case is, I want to make sure people in the whole of Thailand have access to a hospital or a clinic within 10-kilometer travel distance. So basically, if you are a public sector organization, and you want to make sure healthcare is easily accessible to each and every person in Thailand, you first start with the population density. So you want to know where people live. I have actually used one example because I don't want to show for the entire country because it's difficult to visualize. But you see Kalasin, I think it's one of the, let's say, in terms of healthcare, one of the most struggling provinces. So I took Kalasin as an example. So in Kalasin, I have the population density. So I say, this is the population in Kalasin. In blue, I see dark areas, and in green are the areas where population is very high. Then I got the data of all the hospitals in Kalasin. So in plus, you see all the hospitals. So you can see that, okay, there are a lot of clinics here, but there is definitely a lack of clinic access here. Now, my use case was to see if every person in Kalasin can access a health facility within 10-kilometer travel distance. So I create a buffer around the hospitals to see what is in the 10-kilometer. So you see here, these are the buffers. So any population that falls outside is in red. That means they don't have access. Any population that are within are in green. That means they have access. So basically, this is what you see. You see that There are people who can actually access a clinic, people who cannot access clinic. Now, this is based on the current data. So you did some diagnostic access to see, okay, the people here don't have access to a clinic, and that is why healthcare outcomes are bad there. Now, the power of prediction comes. Let's say I want to construct hospitals, because you don't construct a hospital for 1 year or 2 years. You want them to sustain for a long time. So first you need to predict where are population going to increase and where requirement is going to increase. The prescriptive power is to tell you exactly where new hospitals have to be placed so that the entire thing becomes green. So as a public sector organization, if the government have an input that this is exactly the positions or exact locations of hospitals that need to be constructed, you can cover the whole population and it becomes 100%. So that is the power of prescription. So you go from descriptive, you go from diagnostic to prescriptive, and the value also increases. This is one example that I wanted to show you to show the power of prescriptive analytics. Going back to my slides, do you see? Yeah, okay. Now, if you consider an example in a food production company, so basically you are a customer-facing food supplier, assume. For descriptive, you can see, suppose your goal is to reduce food waste and loss. So as you know, food loss and waste is a huge issue because almost 1/3 of all the food in the world is either lost or wasted in the entire supply chain. And this is a global problem, not just in Asia, it's really a global problem. So in the descriptive part, what you could see is how much waste is generated monthly or yearly or weekly, and how in which part of my process is the waste generated. So that is more descriptive. When you go to diagnostic, you can see why is waste generated. Is it because of bad packaging? Is it because of overproduction? Is it because of logistics or supply chain? So you can really diagnose why waste is being generated. Now, my ideal goal is not to understand why, but my goal is to reduce food waste. So in predictive part, what I want to do is I want to predict consumer demand so that I don't overproduce. So basically in diagnostic steps, suppose I got the idea that overproduction is a cause for food waste, then I try to predict what customer demand is based on different seasons. Then in prescriptive, I will optimize my inventory levels. So stock and how much to send where, all of this information based on my sales and the seasonal information. And I will try to maintain inventory levels that will actually based on mathematical modeling and scenarios. So usually in descriptive, you need a lot of business intelligence tools, data visualization power. In diagnostic, you really need to delve deep into the mathematics of it, like correlation and maybe some linear regression and so on. In predictive, you really use machine learning. And in prescriptive, you generally use optimization models. So these are the technical things that you use behind it. But this is the general framework and the idea of all these applications. And whether you are working in a company or you want to have your own startup, understanding these steps could be very valuable for you because you can easily relate this to your use cases and your problem statements. This is one thing that I really like because this is the data science life cycle. The life cycle of any data science project should not start with the data itself. So what big companies these days do is they just, without any consideration of privacy or other things, just collect data. They just want to have big data, but they don't collect for a particular reason. They don't collect with the business use case in mind. A lot of AI startups as well fail because their goal is actually to create an AI startup, not to solve a problem. So that's why any data science product should start with a business understanding. So you need to define what problem you are trying to solve. Then you check in your database or in your network, do you have the data required to answer that question? Suppose you don't have the data, then you go for data acquisition. Now, in some cases, when you define the problem and you don't have any data, you can go for like some kind of scenario modeling. You can simulate your own data. That's why there is an arrow to here as well. So you can actually do some simulations to test your model with developed data by yourself instead of collecting the data, just to test your models. Now, if you understand your data very well, then maybe you need to develop or deploy some dashboard or something. So it actually goes to a deployment phase and customers can accept it. And every time before end, you have to have customer acceptance. You need to test who is going to use your model, who is going to use your dashboard, who is going to use your product. That should be very clear in your mind right from the starting. Because these days, that's why I love the Steam platform, because you have the A in it, which is actually about making sure you have a user interface and a user experience that is in aligned with your product, in aligned with your designs. So you really need to consider, because these days UI UX is a inherent component of any application. So you really need to focus on UI UX. So that's why the customer acceptance is also very, very important. Now here I have added some links. So if you want to know more about what kind of tools, what kind of environment, like sometimes you deploy on cloud, sometimes you deploy on your own laptop to test your model and then move it to cloud. So there are like a lot of technical things behind it. Maybe we will do a deep dive session later on, but also during the mentoring, if you think your use case, you want to dwell deep into one of these, maybe a modeling or maybe a dashboarding, we can discuss this in a one-on-one mentoring session as well. Because I think if I have to go deep into each of these, it will take a long time, because technical aspects is, according to me, learning the programming language or the technical aspect of it is secondary to the framework. So you really need to get that data science thinking mindset, which will allow you to define use cases from data. After that, the tools and techniques and the hands-on experience can come by practice. Now, I hear that a lot of you are from healthcare and food processing fields. So I looked at a few startups that could be good examples for you. And I want to point out a few things across the innovation ecosystem. So other than being a data scientist, I really love working closely with the innovation ecosystem in different countries. So I really love not just participating in hackathons, but I also organize hackathons. And this is one way to work closely with the innovation ecosystem in a country. So I use these as examples to make a point. So first one is iCarbonX. Basically, they want to digitize the health of everybody in the country. And it is only one of the 3 Chinese healthcare startups that are considered a unicorn. And they have a lot of biological measures from individuals. They also have, they also use advanced AI from your smartwatch, your sensors in your smart devices, and so on. So including your mobile phone. So they are basically collecting all this information and offering diagnostics. The second one is Med247, which is a Vietnamese startup that operates medical apps and care facilities across Vietnam. And they are basically a hybrid platform and they offer telemedicine. So due to COVID, a lot of other diseases went under noticed and people were literally like scared to just go for tests and checkups with the fear that they will get COVID, and they were all at home. So telemedicine became really popular in many parts of the world, and one of that is Med247. The third one is Avis Health, which is a wearable stethoscope, which can actually continuously monitor the health of asthma patients. So some of them are like generic, which can cater to different kinds of diseases and diagnostics. Some of them are very specific, for example, for asthma, for cancer, like specifically for devices. While working in the healthcare sector, I want to make one point to think about is data privacy and ethics is of utmost importance. So suppose you have a model, you are predicting it wrong, or you are not publishing your results in a manner which people can really understand the complications behind it, it becomes very difficult for people to trust it and use it. Secondly, you really need to consider the ethical sense of all the data that you are collecting. Is it actually personally identifiable information? Because medical records, nobody wants to have it in the public domain. So when you work in the healthcare sector across all these three, I think it's very, very evident that the data that they collect is extremely sensitive. So when you're working in the healthcare sector, two things: your model should be very transparent in a way that people know what is the metric. If you say accuracy, 90% of the time, the model is right. That doesn't say anything. That actually doesn't say how trustworthy or how replicable your model is. So you really need to dwell deep into how good your model is before deploying it. Secondly, be aware of the ethical considerations of the data that you collect and be extremely responsible with it, because it's very, very sensitive information. The next set of applications that I want to talk about is data for food systems. So in food systems, there are a lot, I mean, it's a huge domain by itself. So I want to only explain about two specifically. No reason behind it, because there is a lot of things. I cannot cover all of it. So I just covered a few here. So the first is data can help you grow more on existing land and use resources more efficiently. So basically using things like precision agriculture, and in conjunction with emerging technology that Arslan mentioned, for example, IoT and others, data can really help you to maximize the yield per acre or yield per land considered. So basically it can actually improve the productivity without increasing your investments in terms of inputs. One of the main things that we see is smallholder farms. So I come from India, and India, most of the farms are very, very small. So not one person will not own like a lot of land. They are all smallholder farmers. So for smallholder farmers, getting access to finance is a big issue. Usually banks do not offer them loans or financial assistance. So in many countries, including Thailand, credit scoring for farmers is becoming very popular, and that is done entirely based on data. So they basically predict the yield, and then they say whether this farmer can pay you back or not. So the banks have more trust, and they can offer financial assistance. So Recult is one of the examples of startups. And I will share the slides with you so you can click on it and it takes you to the page. So everything is here. The second one is it can also maximize. So indiscriminate use of fertilizers are destroying the ecosystem. So it destroys the soil. It actually, short term, maybe it increases yield, but in the long term, it causes a lot of loss for the farmers. So how much fertilizer to use where, and what kind of organic matter is required in the soil. So these kind of prescription and prediction can also be done with fertilizers. The fourth one here is precision agriculture and automation solutions to close yield gaps. So basically a lot of farm work can be based on your experience. So farmers usually have their own experience that tells them what to do. But recently there are like climate adverse effects that the farmers are not able to predict or to think about before itself. So it makes it very difficult for them to change their cropping pattern or schedules in response to the climate adversities. So this is why precision agriculture and automation is becoming more and more important. And availability of irrigation facilities also is becoming very important because of this. Sorry. The second set of applications is on reducing the waste. Like I said, that's a very big issue throughout globally. So can you actually forecast demand and based on that produce food so that you don't waste food? Also based on our metabolism, based on our health conditions, can you prescribe what amount or how much food should I eat? So that kind of things is also becoming very popular, like recommendation systems for individual diets. We also have dynamic pricing of food, because what is happening, at least in Europe, what I see is that if you go to a supermarket, if the food is like going to be expired tomorrow or day after, then you get it at a reduced price. So basically you purchase it and you have to cook it the same day. Whereas food that is having a bit more expiry date and are more fresh, the prices are high. So this kind of dynamic pricing can actually help consumers get them at a reduced price, but the consumers just buy what is needed and they use it immediately. So they don't go and the food doesn't go to waste. So dynamic pricing is actually being done in Europe. I'm not sure whether it's already there in Thailand. Also, traceability to increase accountability is becoming very, very important, because when we eat food, we ultimately think that it is coming from the supermarket, but actually not, right? It comes through a long process. So how can you say where my food originated and what were done to my food in terms of packaging, processing? That kind of traceability is becoming more prominent, and for this they use data. And Arslan already mentioned about blockchain. There are a few countries also experimenting with blockchain for ensuring traceability and transparency in the food supply chain. So these are some of the innovations that I thought could be interesting for you to think about. Now, to conclude, I think I gave you a bit of overview on what is data science and what is possible with data science. We looked at descriptive, diagnostic, predictive, and prescriptive analytics. We also looked at the entire life cycle of a data science project and how you start and how you end a project. And I also gave you a few examples of innovations where data science have played a very important role, especially in healthcare and food systems. With this, I come to the end of my presentation, but I want to show you a few things. Well, I was not sure if I have time, but these are some dashboards that I wanted to show you. How do I, yeah. So let me share my screen again, because I don't, do you see a dashboard? A world map? Okay. So this is a hunger map of the world. Why I show you this is just to show that data is not just one type of data. So this is what we call as geospatial data. So you click on a map and it's based on geospatial information, and you can zoom in, you can zoom out, you get information based on latitude, longitude, vector files. So this kind of a data ecosystem is geospatial data. And it's becoming a new field called spatial data science. And there are a lot of startups coming up in this domain as well, because there is a lot of satellite data available now. Some free, some non-public. So this is World Hunger Map, which I really like, because it's designed very well. And yeah, it's a very good example of using geospatial data. Now, this is a traditional, I think most of us have seen this. This is a Corona dashboard by Johns Hopkins University. So basically, this is not geospatial data. This is basically a structured data set. So this does have latitude, longitude points, but it's not vector files, or it's not highly granular spatial data, but it's more what we call as structured data. So I just wanted to show you two examples of different types of data. So this is a geospatial data. This is structured data. We also have data like text data, which requires a separate analytics. Like all the social media information is usually stored as text data. So this just to give an overview of the different types of data sets. That's it from my side. Do you guys have any questions? I really hope you do. Or if you want to tell me more about what you're working on, we could maybe have a discussion on how we can use some of these things that I discussed here and how you can incorporate into your projects.
Hello, Parvathy. I have some questions.
Yes.
I would like to ask you what you think about which part of doing data science is the most challenging for you?
Challenging in terms of technical challenges?
Yeah, that's it.
So to be honest, when I start working on a project, defining that business case or the relevance to the user is usually more difficult in the whole process. But in terms of technical deployment, Scalability of the application is usually the most difficult. Like, let's say I make an application which can be used for 100 people. How do you do the data engineering behind it to scale it to 1 million farmers or 1 million users? That scalability of the application in terms of the backend required, the data engineering usually is more tricky.
Okay, thank you.
Any other questions, comments, feedback, anything? Maybe one of you can tell me what you are working on, then we can, if you think it have relevance to what I discussed right now, so we can maybe give the others also a flavor of how a live project can be defined in terms of prescriptive or predictive.
Hello, Parvathy.
Hi.
Kamjir, I have some question for you.
Yeah, sure.
When we give a data set of data science, and when we want to use all the data, how we analyze the data from AI or from the human?
Yeah, very interesting question. So why did this whole thing of data science, of Python or machine learning, all this come is because suppose you have a data file which is 3 points or 4 points or 5 points. You can analyze it yourself, right? I mean, as a human, I can easily calculate what is the average, median, whatever, it does not matter. Even I can easily see correlations between the data. But suppose the data is huge or the data changes every time, it's not easy for us to analyze it ourselves. It becomes very difficult for, let's say, our minds to process it that much fast. So big data, as they call it, is about volume. So it's just the enormous amount, the quantity, the veracity, velocity, let's say, that is the speed at which it comes. Maybe it's very fast. It changes every moment. So you cannot really do computations on the fly. The third one is veracity. So that is the different types of data. So taking the example of the healthcare system that I talked about, right? To completely understand it, we need the population data, we need healthcare data, we need to understand which people are actually requiring a healthcare facility. Let's say older population maybe require more, mothers require more. It also need to know where the roads are located, because just because there is a hospital doesn't mean I can go there. I need a road network. So we need a lot of different data sets to make a decision. So for those, you really need data science and machine learning. You cannot do it by just human alone. But that being said, I think data can give you insights, but what to do with that insights and a human-centric approach have to be done to solve a problem. So I don't think data can solve the problem. I think humans can solve the problem with the help of data. So we definitely need a human in the loop approach for all the machine learning things, according to me. Thanks for the question. It's a really relevant question. Thanks.
Yeah. In Thailand, most of the farmers are older people, and they are very reluctant to use technology, especially digital technology. So, like, for example, in India, how did you get farmers to use digital technology?
So in India is a predominantly, let's say, younger population. So, but I can give you example of another country that I am currently working on. There, the same way, farmers are not digitally inclined. So what we can do is, instead of trying to train all the farmers to use it, we create farmer producer organizations. So we club a group of farmers to a small decentralized small units or groups. Then we identify farmers or people within that group who can help the farmers use these technologies. Because ideally our goal is to make the farmers capable to use the technology. They don't need to understand or develop it themselves. They basically have to use it. So if you cannot train them to directly use it, you can form smaller groups where they can communicate, they can easily give the insights from it. One example is weather advisory. So you tell a farmer that you send a very complicated graph to the farmer and say, yeah, the temperature is increasing, the flood risk is high. The farmer is not going to understand anything. But suppose you send a text message to the farmer in the farmer's own language and tell that the weather is going to be bad, this is what you should do. So give them suggestions and like I said, actionable insights, something that they can take an action on. It becomes easy. So that's again going back to my point on being user-centric. So your solution should be perfect for the user. If it's not hi-fi, it does not matter. If it doesn't use the latest AI models, it does not matter. The user should be able to use it and get insights from it and do something about it. So yeah, that would be my answer. Be innovative in terms of how you deliver your message. The technology doesn't matter. Could you give the example of your project related to sustainability that data science can really help to solve the problem? So in terms of sustainability, there are a few projects that I work in. Because you are a predominantly, let's say, healthcare and food, I'll talk about one of the healthcare problems. So the Thailand example that I showed you about locating health facilities and telling the government exactly where to place those facilities, we have done it in Timor-Leste. So Timor-Leste is a small country. It was part of Indonesia some time back. So Timor-Leste have issues with healthcare access. So we did the exact same thing that I showed you for Timor-Leste, and we told the government that people here don't have access. This is where they need to construct new hospitals. One of the other applications that we currently have is for farmers. Basically, for farmers, they need access to markets. So farmers need information to know which markets are where they are located and what is the price of commodities in those markets. They also need to know whether they need to store their products, because most of the farmers don't have access to warehouses or storage facilities. So we tell the government these farmers are producing highly perishable commodities, especially horticulture products, because yeah, in India at least, people are very scared to grow fruits because yeah, they are highly perishable. But if you have like storage facilities strategically placed by private partners or government officials, you can increase the life of these products and they can easily store them. And creating these farmer producer organizations or groups really help the farmers to come out of this thing of using middlemen for everything. Because see, ultimately our goal is to increase farmers' income, at the same time reducing the input. So how do you do that? By giving them access to information at the right moment. That should be the, I think that big data can really help. But if you look at SDGs in general, any SDG you take, you will find relevance to of big data. For example, if you take gender equality. So one of the organizations here, due to privacy, I don't want to mention the organization. One of the organizations here want to really see whether my company is gender neutral in terms of salaries and hikes. So what they did is they analyzed all the HR information. So the HR collected a lot of data, and they really saw disparity in income within the organization. Are women being promoted less, even though they have the same qualifications? And it's a huge country. You cannot manually do the analysis. And some information is in text, some information is in interview exit forms. So they actually did a big analysis and they found out where they need to solve the problem. So that is actually the SDG on gender equality. So you take any SDG, you can find one or other examples of using big data and yeah, artificial intelligence. There's some questions in the chat.
Yeah, there's a question on the preparation for mentoring. What do they need to prepare? I think Kanok is a faculty member, professor in Takshan University. Yeah, she's the one who talked about her biotech. She has a lot of interesting bioremediation technologies to solve waste, to clean up the pollution in the environment. So I think a lot of our colleagues here, our trainees here, are very interested in either cleaning up the environment, creating social impact. This is really the SDGs. I mean, a lot of SDGs as a purpose for their entrepreneurship. And so I've got Pop talked about sustainability, right? So I think SDG is very specific goals for sustainability. So if you look at environmental, social, economic sustainability, the three pillars, I think Parvathy has done a lot of work in this space, right? I mean, especially on the specifically different SDG goals.
Yeah, so for the mentoring, yeah, I would like if you come, I mean, we will more have a discussion. So it will be very informal. So there is no need for preparing anything in advance. But if you come with a example of a problem that you have tried to solve, or give me more details specifically into projects, I think I can help more than having, let's say, vague ideas, because if we have like specific questions, we can have a very more productive discussion. And I think, let's say you have an experiment that you are running and you want to see how data can be collected, or yeah, anything. So I think it can be very informal. Yeah, I don't want you to prepare anything. We can have a discussion. And yeah, I'm really looking forward to hearing more about your innovations. Lavin have told me already a lot about this group of trainees, so I'm very much looking forward to the mentoring sessions.
I have a question if you have a few times. Yeah,
Go ahead.
Hi, Parvathy.
Hi.
I interested in about that you mentioned about the human-centered design. So do you have an example for understanding the customer or user behavior? Let's say for example, mental health care, that to understand about how they okay. The main point is how to prevent or to decrease the time people use the mobile phone, let's say, for example. But the solution is the application mobile phone for them to, let's say, for them to decrease their mental illness by using the phone, application. Mm-hmm. So I would like to know that how data science or the data analysis to understand and decrease, because it's kind of the conflict of interest that at the same time we would like to decrease, but at the meantime that hey, we would like people to use it as well. Do you have any idea or recommendation for this? Thank you.
Yeah, so this is like you said, it's conflicting, but it's also at the same time very relevant, right? So to reduce screen time, but actually using an app. In my laptop, I actually have an application that actually pops up and say, yeah, you have used already 3 hours. You should not use anymore. Just shut down. And there is actually a X next to it. And 90% of the time I just click the X, which is not ideally what you should do, right? Like, how can you motivate the user to do that? So for this, there is some field called process mining in data science, which is very useful. So basically what process mining tells you is it shows you the process a user goes through. So let's say it tells you that if I give this alert at this time of the day, my user is always clicking X. Or if my user is shown this 3 times in a day, it's muting the notifications. Or if you show it after a particular incident, or while I'm using another application, I'm always closing it, because this is actually showing you the process that the user takes while using your app. And this is being used by all the websites and mobile applications to increase the user interface and the user experience. For example, booking.com, it's a company here in Netherlands. Basically what they do is they follow the user's click, and you make the whole process. and you identify the bottlenecks, like where is the user spending the most amount of time. That is not good. That means the user is kind of stuck. They are not able to go to the next step. Then they see that exact step and they try to reduce that. So they help in identifying bottlenecks, in improving your user experience. So process mining is something that you can explore. I will just make a note of this because I can send you some references for this. Yeah, for the whole group. If you find it useful, you can use. But process mining is becoming very popular, and there are tools, a lot of new softwares coming up to do process mining as well. So you can explore this field.
So it means that to understand the data science, sometimes we need a psychology as well to define the problems, and let's see that which one is the main thing to solve, and also utilize the user experience as well. Am I understanding is correct?
So I think for a data scientist, the apt quality to have is empathy. So you can always sympathize with your users, but that's not enough. You really need to empathize with them. So I have read a lot of research on this, and with my personal experience, I think if you can empathize with your users, you have a successful product. So it's not just psychology. You really need to put yourself in the shoes of your user and try to think, okay, if I'm a farmer and I don't have enough experience, because we are all educated, the way we use an app is not the same way somebody else is going to use. So how do you actually put yourself in that shoes? It's very, very difficult. But if you can do that, you will be, your app or your solution will be successful. Yes.
Thank you so much, Parvathy. Thank you, Levin.
Okay. So any other questions? Let me invite Parvathy in the group as well. We have a, so now again. So Parvathy, I invited you at the strategic communication training line group. So you can see all the trainees there.
So I will share.
There's so much to explore at data science. It's a huge field. And so if you guys could leverage this opportunity and have a one-on-one session with Parvathy, I think you will find it very, very helpful to see how data science can help you with your work. Actually, Parvathy also runs her own consultancy. She has the so-called data scan program, right? So if you like for any organization, any company, startup, SME, any company, she can come in and do a little data scan for you to see what's required and how data science can be helpful for you as well. So I think maybe Parvathy, you can talk a little bit on that, how you help companies solve their problem or adoption of data science in their business or entrepreneurship practice.
So data quick scan is basically just to look at a startup, the idea itself, and to see what kind of data should be collected for specific problem statements. So the data quick scan just look at, for example, I see in the chat that somebody is building a startup which is for preventive healthcare in Bangladesh. So basically, you need to identify in Bangladesh what are the problems. You need to see what is meant by preventive healthcare. So what are the diseases that you need to target? What kind of data need to be collected at individual level? So we kind of give a report on all this. We also look at the current data being collected and give some ideas on how you can use the data for what, and build some models on top of it and so on. So I do this mostly for startups because big companies already have big data science teams within them. But for startups, it can really, really add value because the whole data science thing is an iterative process. So you cannot really do one data science project and then that's it. You need to do one project, then you need to improve it, you improve it, and then you get the big solution. So even companies like Netflix, which are like having recommender systems, they hire a huge team to iteratively improve the algorithm to add to the backend. So even as startups, this iterative, like fail fast and improve the next round, that kind of a mindset can be brought in with the help of data science. So we try to go and bring in that change in companies. I have worked with a lot of Indian companies, but yeah, I don't never got the opportunity to work with a lot of Thai companies yet. But yeah, I look forward. Maybe Lovin, we can collaborate further on this.
Yeah, absolutely. Yeah, so I think Parvathy, during your PhD study, at least 50% of the time, at least, you work with companies, right? You actually you work directly with the company, helping them solve their problems. Can you give maybe an example of how you do that? How you actually help some of the companies solve some critical problems in their business and adding value?
So what I did is not a traditional PhD program. So it's called a professional doctorate in engineering. So it's a 2-year program, which is only available in some European countries. So they hire like 6 or 7 students a year. That's it. They don't hire more. And what they do is they put you in companies and then they ask you to solve their problems. So that is done. Let's say we did in the first year, we did like 5 companies. And then in the second year, we worked continuously in 1 company. So the first year we did like I said, we did circulation, like we circulated among different companies. So we go in, we try to identify the problem and solve them within 3 months. So we only had 3 months per project. And the good thing about this project is that they are all from different sectors. So I worked with the electronics company, I worked with the healthcare company, I worked with the government entity and so on. So you get the domain expertise and the ability to work with these startups. And in the second year, the whole year, I worked with 1 company. It's called ASML. It's a semiconductor company. It's a global organization. It's called ASML. So there, what I did is exactly process mining. I tried to look at their process and then try to identify what are the bottlenecks in their process, how to improve their supply chain. So I did supply chain optimization, I did logistics and warehousing optimization and so on. So yeah, I actually will send you this link if you are interested in doing a more not a traditional way of PhD, but want to work closely with companies. It's more of an industry PhD doctoral program. So yeah, you can take a look. I'll put this in the line group as well. But it's an experience to work with different sectors.
Can you give an example, like in the healthcare sector and government sector, what sort of a problem that you have helped them solve? Okay, if you don't break the confidentiality, just no name mentioned. I know you have NDA with those guys, but just kind of conceptually.
So the published things I can talk about. So with the healthcare sector, what we did is something different. So you always talk about healthcare in terms of physical health, but the project I got to work with was actually mental health project. So it was about happiness of children, especially expats in the Netherlands. So when you actually move from a different country and you come to Netherlands, what are your chances that the kids gel very easily with the community, and what are the challenges that they face? Do they actually have access to kindergarten? Do they have access to parks? So we did a geospatial mapping of all the facilities, and we tried to identify areas or communities that don't have access to all of this. And then we tried to we told the government, it was also a partial government entity. So they did some interventions there. For example, they did counseling, they constructed a playground. So we tried to do targeted advisory for which part of areas to focus on, but from the perspective of expats. And we did some metrics on mental health, like for example, we did on ADHD, prevalence of post-traumatic stress and so on. So we did array of tests and we got a lot of information, but all were not personally identifiable information. So we did it at a district level. So you cannot really know exactly where these kids are from, but you know they are from a specific district. And we were never told their ethnicity. So we don't know whether they are Indian or they are Thai, or we never know that information. It's hidden. So we actually developed a framework for them to anonymize the data. Then we gave this feedback to the company. So then they anonymized the data and then they gave it to us. Then we did that analysis, because they didn't know exactly how to anonymize it as well. So as a government organization, they didn't have data scientists to anonymize the data. So first we like advised them on the anonymization technique. Then we did the analytics on the data. So that was actually a really good experience for me as well, to learn about PII, like personally identifiable information, and how to work with sensitive data. And with governments, yeah, there are a lot of projects. Sorry, yeah, go ahead.
The government, yeah, go ahead. The government institution, because some of us are working at the government's public sector, to see how, I know you also work on government tech, was it GOV tech as well. So
Yeah.
how making policies, right, using data.
So we, with the government, usually with World Bank and UNDP, what kind of work I do is geospatial planning and budgeting. So let's say they have a budget, where should they spend? Like, should they actually construct roads or construct hospitals or construct schools where? So kind of a planning and budgeting platform for governments. I have also done a series of projects on ease of doing business. So in a country, what is the bottlenecks in the ease of doing business? Like, for example, I want to register a startup in Thailand. Do I know the exact process of registering a startup, and where are the bottlenecks? Like, does my application get stuck at the first step or at the last step? And then the government can actually increase the ease of doing business index. I think this is very relevant across different application process of governments, right? So not just starting a company, even getting an electricity connection or getting your passport, getting your visa. So every business process can have the ease of doing that. I have also worked with the different teams within a government entity. For example, emerging technologies wing on using blockchain, using other emerging technologies as well. Also how to bring in direct intervention in the policy itself. And what is the impact of a policy? For example, you have a policy, does it actually make any difference on the ground or not? That is very, very rarely measured, because suppose you want to improve the nutrition of a district, and you give them free vegetables and fruits for a year, and you then just disappear, the whole area goes back to being deficit again. So any government policy or intervention should have long-lasting impact. How do you measure the impact? How do you sustain that impact? This can also be done with data science. I think those are things that can be explored. Lovin, you are on mute.
Yeah, there's a lot going on. Personally, for example, we are designing policy instrumentation for circular economy for government. So we really need to look at those data. Unfortunately, sometimes government don't give us the data. So what do you do when you have difficult accessing to data? Because some data in the government is not available, or they are not ready to give it to you. How do you overcome this obstacle?
So we usually try to look for open source data sets. There is a lot of data available in the open domain, which is not used. If you don't have data, you see exactly the need for a startup to collect the data. So startups or companies don't always have to be analyzing the data. They could also be providers of data itself. So I know a few examples of companies that generate this. Secondly, what I see is the barrier for governments to share the data is because they don't see the value. So suppose if we tell the government, okay, suppose I have so-and-so data, I'm going to give you this result. Then they are more happy to share data than saying, can you please give this data for me to analyze?
Right. Yeah.
because they don't see the value. So I will not blame them for not giving data because it's extremely valuable information, and they are many cases don't have the time to involve in these activities without seeing the value. So if you tell, if I have this data, this is what I can do, and this is, I have like a proof of concept ready, then you say, and this one I have made with open source data. Can you now provide me with the official data? The same example with the healthcare centers. I showed you the example with Thailand, right? And that's all based on open data. Now, if I tell these results to the healthcare department and I say, based on health open data, this is what I see. Can you please now give me access to the official data? They of course will give, because they see what can be done with it.
Yeah, excellent.